What's up, S cubed people? As we go through all of our lessons the next couple weeks, I'm going to try to keep them short. We picked out some lessons and some skills that are critical for you to be successful when you move into seventh grade. So they're basic skills, but they're important ones that you should try to really focus in on improving this summer. So the first thing that we're going to look at this week is adding and subtracting fractions. So it's not a big lesson, but I'm going to go through some of the key points and go over some examples, and hopefully you can use those to more successfully complete your work. So the big thing with adding and subtracting fractions is no matter what, any addition or subtraction of fractions, you must have common denominators. So you need to make sure that the denominators are the same. So before we even get into that, let's very quickly talk about the parts of a fraction and make sure we're up on that. So if I had the fraction 3/7, the number that's on the top is known as the numerator, and the number that's on the bottom, that's the one we're talking about here when we say common denominators. We want to make sure that this, the denominator, is the same in both of the fractions that we are adding or subtracting. So let's just jump right into an example problem, okay? Let's take something very basic to start. Let's say we had 2/3 plus 1/4. Very simple. You cannot simply add it like this. That's not correct. Fractions need to have common denominators when you are adding or subtracting them together. Multiplication and division does not require common denominators, but we're talking about adding and subtracting today, and those two operations do. So what you're asking yourself then is thirds and fourths. What can both of those numbers turn into? A lot of people will call a common denominator the least common denominator. You're looking for the lowest number that both of these can turn into. So for example, 3 has multiples 3, 6, 9, 12, 15, 18, etc. 4 would be 4, 8, 12, 16, 20, etc. What's the smallest number that both of those can turn into? Well, I know that thirds can turn into twelfths and fourths can turn into twelfths. And the way that I can do that, I'll do it on the side here. 2/3, if you multiply it by 4, 3 times 4 is 12, so there's my twelfths. And we're going to multiply the numerator by the same thing. 2 times 4 is 8. So 2/3, we're just making it into a bigger version of itself, 8/12. It's still the same fraction. So now we've got 8/12 plus, and now 1/4, we need to turn that into twelfths as well to have a common denominator. So I'm going to multiply this fraction by 3 because 4 times 3 is 12. And 1 times 3 is 3. So 1/4 is the same as 3/12. We're using the twelfths version of the fraction because now I've got common denominators. So when you add or subtract fractions, it works the same way for subtraction. The denominators, the number that's on the bottom, is going to stay the same. So I've got twelfths. How many twelfths do I have? Well, I have 8 of them and 3 of them. So in total, I have 11 twelfths. So the answer to our original problem, 2/3 plus 1/4, is 11 twelfths. And you do that by step 1, find common denominators, rewrite your fractions, and then add the numerators. The top number is 8 plus 3. And that'll tell you how many twelfths you have. It works the same way for subtraction, except instead of adding the numbers on the top, you would be subtracting the numbers on the top. But we're going to look at a different scenario now. What happens if you have mixed numbers? First question is, what the heck is a mixed number? So mixed numbers are fractions that have both a whole number part to it and a fractional part. So for example, let's say I had the fraction 1 and 1/3. This is a mixed number. So my question is, if you're adding or subtracting mixed numbers, what happens? Well, nothing really different happens. You still need to have common denominators. So let's come up with an example problem. 1 and 1/3 plus 6 and 1/7. All right, Step 1, focus on just the fractions. The whole numbers we'll come back to. So the fractions, I've got 1/3 and 1/7. Clearly, they do not have common denominators, and I need to make them have common denominators. So what I'm going to do is I'm going to multiply this first fraction by 7, and that's going to give me 21 in the denominator and 7 in the numerator. And I'm going to multiply the second fraction, 1/7. I'm going to multiply it by 3, because that's also going to give me a denominator of 21. And now I have common denominators. Now I can go about adding these two mixed numbers. So first I'm going to rewrite the problem. Now instead of 1 and 1/3, I have 1 and 7/21. And now instead of 6 and 1/7, I have 6 and 3/21. You do not have to do the next thing that I'm going to do, though some people find it helpful to keep things organized. When I have mixed numbers, I tend to rewrite the problem so that it is, instead of going left to right, I write it so that it's going up and down. So I'll show you what that looks like. I would write this as 1 and 7/21 plus 6 and 3/21. The reason I do this is because then I have my whole numbers lined up and my fractions lined up, because I'm adding the fractions together and then the whole numbers together, and then I'll have a final answer. So I'm going to add the fractions first. Remember, when you're adding or subtracting fractions, the denominator stays the same, so it's over 21. And I'm just adding the numerators. 7 plus 3 is 10. And then I'm going to add the whole numbers, 1 plus 6, which is 7. So the answer to my original problem, which was 1 and 1/3 plus 6 and 1/7, is 7 and 10/21. Again, you would do the same thing if you were subtracting, but instead of adding the numbers, you'd be subtracting the numbers. One more example problem, and then we're done with this video lesson for today. My last thing I want to look at is when you are subtracting. Sometimes when you're subtracting, you're going to come up with problems that look like they're not possible. And you might have to do something called borrowing. So let me go over what borrowing looks like. Let's say you had the problem 3 and 1/7 minus 2 and 5/7. Well, I already have common denominators, beautiful. But the problem here is 1 minus 5. And I'm looking at just the numerators here. Remember, we got to subtract our fractions first. Well, you can't do 1 minus 5. I would need it to be 5 minus 1, but that's not what it says. It says 1 minus 5. So when you come to a problem where you're subtracting and the numerators, the numbers on the top, they can't subtract, first off, please don't do 5 minus 1 and just write 4. That's not what the problem says. It's 1 minus 5. But there is a workaround. There is a way to fix this, and that's with something called borrowing. And I'm going to show you what that looks like. Borrowing, when you borrow something, you take something from someone else and you use it. So we're going to do that here. This fraction that has 1/7, it needs to become bigger so that it's bigger than the 5. So what it's going to do, we're going to take 1 whole away from the 3. So if I take 1 away from 3, it becomes 2. So I took 1 away, 1 whole, and that reduced it to 2. And I'm going to take this 1 whole and I'm going to give it to this fraction. I'm going to make this fraction bigger. Really, I'm not changing anything. I'm just shifting around where the numbers are. I'm taking something from here and I'm moving it to here. It's still the same amount. It's still 3 and 1/7. We're just going to write it differently. Now, the one thing is, when you borrow, you need to think, if I'm taking 1 away and I'm giving it to the fraction, what is 1 in fraction form? And in particular, in fraction form when we have sevenths. Well, 1 is the same thing as 7/7. Let's say your denominator was thirds. 1 is the same as 3/3. Or let's say you had twelfths. 1 is the same as 12 twelfths. So this will work with any fraction. You're always going to use the denominator that's in the problem. So we're using sevenths. So back to what I was saying. We took 1 away from the 3, reduced it to 2, and we're going to give that 1 whole to this fraction. So my 1/7 is now going to increase by 7/7 by 1 whole. So what happens when you add 7/7 to 1/7? Well, that's going to change this fraction to 8/7 because 1/7 plus 7/7 is 8/7. And now I have a brand new problem, and I'm going to rewrite it so it's easier to see. Instead of 3 and 1/7, I have 2 and 8/7. And what did we do? We took 1 from the 3, reduced it to a 2, and that 1 whole, aka 7/7, we added to the 1/7 and made it 8/7. And the reason we did that is now I can subtract quite easily. 8 minus 5 is 3. So 8/7, take away 5/7 is 3/7. I can subtract 8 minus 5. Before I couldn't subtract 1 minus 5. And then 2, we're focusing on the whole numbers now. 2 minus 2 is 0, so there's no whole number part to this. So your final answer is 3/7. 3 and 1/7 minus 2 and 5/7, final answer, 3/7. And so this is what, if you ever come up with a subtraction problem where it looks like, I can't subtract the numerators, like 1 minus 5, you'll need to borrow. Anyways, if you have questions with the work, please feel free to reach out to us. Otherwise, when you're doing your work, get a nice clean sheet of paper, try to clearly show the steps of what you're doing, number each problem, and then circle those final answers so that when we're checking over your work, we can easily see what you came up with and can give you some feedback to improve if you need it. Otherwise, good luck and enjoy the rest of your day otherwise. See ya!